Today, we're going inside the browser to see how HTML, CSS, and JavaScript become the web page on your screen. Once you understand this process, debugging gets easier, performance finally makes sense, and frameworks like React become much easier to understand. Ever wondered why a website feels slow even when the JavaScript is small? It's usually not the JavaScript, it's the browser's rendering pipeline. That's why companies like Google, Netflix, and YouTube spend so much time optimizing it, and why it's one of the most common front-end interview topics. Let's build a small page and watch how the browser renders it step by step. Create a folder named browser-render pipeline with 3 files: index.html, styles.css, and script.js. Open Chrome DevTools because we'll inspect the browser throughout this lesson. Chrome doesn't immediately draw your HTML. First, it reads the document, understands its structure, and builds an internal representation. This process is called parsing. We can simplify a browser into 4 major parts. Browser UI handles tabs and navigation. Browser engine coordinates everything. Rendering engine draws the page. JavaScript engine executes your code. The browser parses HTML and builds the document object model, or DOM. The DOM isn't your HTML file. It's a live tree of JavaScript objects stored in memory. JavaScript works with the DOM, not the original HTML file. Open the Elements panel. Everything here is the live DOM. Change the heading directly inside DevTools. Notice the page updates immediately while the HTML file stays unchanged. CSS is also parsed. The browser converts every selector and property into another structure called the CSS object model, or CSSOM. The browser combines the DOM and CSSOM into the render tree. It contains only the elements that actually need to be displayed along with their computed styles. The paragraph still exists in the DOM but disappears from the render tree because it isn't rendered. First, the browser calculates the final styles for every visible element using the CSS cascade and specificity. Next comes layout. The browser calculates the exact size and position of every visible element. Paint fills those boxes with colors, borders, text, shadows, and images. Finally, the browser combines layers, often using the GPU, to produce the final image on your screen. JavaScript doesn't draw pixels. It changes the DOM or styles, and then the browser decides which rendering steps must run again. Not every DOM change costs the browser the same amount of work. Changing text or colors usually triggers a repaint, while changing an element's size or display often requires both layout and paint. Properties, like transform, are typically the most efficient because they can be handled during the composite stage. Knowing this helps you write smoother, more performant web applications. Changing width forces the browser to recalculate layout. This is called a reflow. It's relatively expensive because nearby elements may also need new positions. Here only the color changes. Layout stays the same, so the browser simply repaints the element. This pattern is slow because every write is followed by a layout read. The browser keeps stopping to recalculate layout before continuing JavaScript. This is called layout thrashing. Open the performance panel, record, interact with the page, then stop recording. The timeline shows JavaScript execution, layout work, painting, and compositing, making it easy to find performance bottlenecks. CSS usually blocks rendering because the browser wants to avoid showing an unstyled page. Normal JavaScript can also pause HTML parsing because it executes immediately. In most applications, defer is the preferred choice because HTML can finish parsing before JavaScript runs. React, Vue, Angular, and other frameworks don't bypass the browser. They simply reduce unnecessary DOM updates before handing work to the rendering engine. This is the complete browser rendering pipeline. Every web page you visit follows this process. Understanding it helps you build faster applications, debug rendering problems, and optimize performance with confidence. You've learned one of the most important concepts in front-end engineering. In the next episode, we'll start controlling the DOM directly with JavaScript to build interactive user interfaces. Thanks for watching, and I'll see you in the next lesson.